excited to come here and talk about optimizing data orchestration for analytics platforms connecting to ClickHouse. Perhaps we can first start by talking about who I am. I'm Gary. I'm one of the co-founders of Explo, and I'm really excited to kind of dive into how our customers actually use ClickHouse and changes that we've had to make to ensure that we can better connect to ClickHouse and query things effectively. So let's really quickly define some terms and kind of chat through what we're kind of talking about here. Data orchestration just means the querying of data and how it kind of flows through a system. In this case, the Explo architecture. The analytics platform that we'll be using in this example is obviously Explo, but in general, the platform itself is like a way for internal or external data analytics to take place. So what is Explo and why does this even matter? Explo builds customer-facing dashboards and analytics. What that means is that we make it really easy for our customers to build an analytical suite that they can then embed directly into their platform for their customers to use. And so to kind of break that down, our customers pay for Explo, but then really the consumers of our dashboard are actually their customers who we call the end user. And so a silly example that I like to give is like, let's say Costco purchases Explo because they want to build out a dashboard for their suppliers to understand how their inventory is doing nationally. They could then use Explo, build out in the platform, and then embed that so that their suppliers will then know, Nike will know how many shoes are in stock in California and how many shirts are in stock in Florida, et cetera, et cetera. And so if I were to break this down, there are kind of like four main parts. The first part that our customer has to do is go into the Explo platform and connect Explo directly to your database or data warehouse. Obviously, we connect directly to ClickHouse. And interestingly enough, one of the most popular databases today that we're seeing an increase in rate of change that a lot of our customers are starting to use is actually ClickHouse. I mean, this actually goes for both our net new prospects that we're chatting with, but also existing customers too, who realize that they need to make various adjustments given their current data hygiene is starting to change and various types of latency problem that they're seeing. Oftentimes we work directly with them, make suggestions about what they want, and nudge them towards using ClickHouse and work with the ClickHouse team directly to help facilitate some of that. Once you have your data connected, the next part of Explo is actually building out the visualizations that you want to utilize. Here's kind of our like WYSIWYG dashboard editor where you're able to drag components from the left-hand sidebar onto the canvas and then start configuring the dashboard that you want. Explo doesn't actually store any of the data. We connect directly to the database or data warehouse. And so in this case, ClickHouse. And so every time the dashboard loads, it will first check the cache to see if it's turned on. If the cache is warm, it'll pull the data from the cache. Otherwise, it'll make a fresh query directly to the ClickHouse database. That will become important a little bit later. Third is that because we are an embedded solution, our customers want it to be completely white labeled so that their customers don't know they're using a third-party tool. And so we have to think about styling, which is not as relevant to this, but it's a very important thing to our product because our product needs to be fully white labeled as essentially an extension of our customers' product team itself. And then the fourth part is actually the embedding part too. And so we give them a code snippet. It can be an iframe or a web component. And in either case, they simply take that code snippet, throw into whatever part of the application that they want. For instance, here we have like a dashboard tab, and then the Explo dashboard will then appear magically. So that's kind of like how Explo works in a nutshell. Some quick examples of what this looks like. Here are some like production environments that I have here, just to showcase like the design complexity, et cetera, for you all to see. Cool. Okay, this is now the more interesting part now that we have some context, which is about the actual orchestration architecture of how data flows through our system and why it's important for us to think very deeply about this, given that's kind of like the backbones of the product itself. So this is the Explo data flow architecture and basically our kind of backend architecture in general. I'll kind of orient towards like this main big screen, but I'll just like talk about it broadly as well. At the top, we have the actual Explo app that connects to our API in the bottom left. The API kind of like is the layer for our entire backend service here. We call it the Explo account in this case. And then on the bottom right, that's our customer account. And so that's like Costco, for instance. Like we don't own that, we don't touch that in terms of like being able to control anything. And so the important part here is that Explo's query coordination has to talk directly to the customer account to be able to query information that is then passed through and shown onto the dashboard. And so this querying could take place from the app itself when you're actually developing and like creating the dashboard, but also when the actual dashboard is embedded, this querying will take place from the customer application too, because dashboard.costco.com will then call Explo's API, which will then call the customer database. And so these customer databases here could be ClickHouse, et cetera, or any other kind of databases that we connect to. And then the connection itself can take place over the public internet, but oftentimes our customers have various types of networking security, kind of what we have to work through. So they either whitelist our egress IPs, or we can SSH tunnel through a bastion or kind of like a jump server that they might have if the database can't talk outside of the VPC that it's in. So this is what our V1 architecture is, and there are a couple reasons why this is not great, or there are things that we can continue to improve. The first is you can think about regions in the world that some of this is hosted. Our backend service is hosted in US East 1, and for an example purpose, our customer cloud could be in AP Southeast 1, which I think is in Singapore. This is bad for a few reasons. One is latency. If we had to SSH tunnel from US East 1 all the way to Singapore and then come back to be able to then flow back up to the app or the customer application, that connection time alone takes around 4 to 5 seconds. If you had to wait for a dashboard to load and it took more than 4 to 5 seconds just to connect to the database, not even query, that's actually a showstopper for a lot of our customers. 2 is actually region-specific requirements. So sometimes our customers work with data that actually can't leave a certain region in the world. So like GDPR is an example for various requirements in the EU. In that case, they actually can't work with our system here because our data, our backend is hosted in US East 1. And so their data is queried and actually comes back to US East 1 before it goes to the browser. And so these are some limitations that we have. The second limitation that I want to call out is that sometimes we work with customers who have very high data residency requirements. And with that, it means that we actually have to think about what hosting Explo on-prem means. And so given the way that it was architected from the beginning, hosting on-prem actually meant we had to host an entirely new backend service that's like, API-eu.explo.co. And that's actually very heavy for us because it's not actually just managing an additional query service, but it's actually managing our entire backend itself, having a separate Explo state, which is our Postgres database. And that's actually very complicated. We actually do that today for a few high-profile clients, but it's not our desired outcome because it's actually very taxing on our team to be able to maintain. The third is that our query coordination, or as it kind of stands today, actually competes for resources within other boxes here. So like the Explo authentication, other Explo services and whatnot. And so we have had times before where when we didn't actually provide enough resource separation appropriately, that the query coordination is actually being starved of some resources from other parts of the application, almost like DOSing ourselves, which is annoying. And then the last thing that we had to kind of adjust is that as it stands today, every single data panel that you see on a dashboard, so chart, graphic, etc., is making a query to our backend, which then queries the customer database. And so every single chart is making its own query request to ClickHouse, for instance, to pull data back to be able to show information on the dashboard itself. Now, the way that the V1 architecture worked is that the query coordination is using non-persistent connections. And so that means that every single one of those, what we call data panels, is essentially making its own connection to the database to query information and then show information back on the dashboard. If we have 10 data panels on a dashboard and we have 1 million people viewing that dashboard, that can scale up to 10 million connections that are attempted to be made to a ClickHouse instance. and that's also troublesome too. So enter Fido. Fido is our internal name that we've called for our like data orchestrator v2, which actually thinks a lot about these problems I just described and tries to solve them. And so the top level way that we actually adjusted this is that we pulled out the query service itself to be its own microservice. So it's a standalone from our backend service, and it actually communicates directly with the application and doesn't have to go through the API itself. The connection that communicates with the customer account and the database is actually just the query service. So our API to Explo.co never actually has to talk to the customer's databases. Yeah, cool. And so there are actually a few benefits here, and they're kind of pattern matched based off of obviously the problems that took place. But one is that because the query service is hosted in its own region, what actually happens is that we could actually deploy a query service in various regions in the world. One in the US East 1, one in the EU, one in APAC, etc. And then the front end, either the application or the embed, based on which customer is actually utilizing the dashboard, will know which region in the world to use like what query service. And so then if we have a customer who's based in Singapore, our front end application will know, okay, query the Singapore related like query service, and then that query time to be able to SSH tunnel from a Singapore-based query service to the Singapore-based database is actually like less than a second, and it's actually very quick. And so that also enables us to access a lot of benefits of like being able to have region-specific stacks that allow us to kind of like fulfill GDPR requirements. So our query service could then live in the EU and make it so that our customers' data, which cannot leave the EU, remains there. It also makes it easier if we ever need to actually host the on-prem, the query service itself on-prem. So the last kind of example I gave is like Explo will host the query service in various regions of the world for optimizations around like latency, data residency requirements. But some customers might actually want, for reasons for like their database is air gapped, it can't actually talk to any service outside of the VPC. We could actually deploy the query service within their own VPC as well. And it's actually much lighter weight for us to do so and manage than it is for us to host an entire backend itself that has to also maintain the other Explo services that exist. Additionally, because it's its own service, it also does not have to contend with other services for resources. So it has its own dedicated kind of set of resources. And then one of the most satisfying things is that we also are starting to connection pool. So each query service will be able to have a set of pool of connections to the actual database itself, which makes it such that when you load a dashboard and there are 10 data panels on the dashboard, we're no longer making 10 unique connections to the database. We have a pool of, let's say, 1,000 connections that already exist that are persisting and they don't actually close. And then we just cycle through all of those 1,000. The 1,000 number is arbitrary, of course, to be able to then cycle through effectively. This actually solves a lot of resourcing issues on our customers' databases as well. Because you can imagine having a lot of open connections, zombie connections, et cetera, is not great for their just like overall database hygiene as well. And so this is kind of like the general benefits that we get from the new architecture that we've built. And we've been seeing a lot of like really good improvements. And so maybe an example of some stats here could be helpful. And so I took one data panel and ran it with the V1 architecture and then switched on V2 and ran the same data panel under V2. And you'll see on the right side is kind of like the stats that we got. So on the right side, remember, because V1 is non-persistent connections, we had to actually make the connection time. So 1.73 seconds for connecting, 0.77 seconds of that was actually the SSH tunneling. There's this amount of like time that has some variance for querying that's dependent on the actual database resourcing at that moment of time, and with a total runtime of 1.96 seconds. In V2, because there are persistent connections, we actually don't have to make and wait for the connection time, and we actually can just go straight to querying, and there's some additional processing time that exists, but it comes out to about a little under 2 seconds of total runtime. And so because of kind of these optimizations that we've made, we've actually found almost a 10x improvement of some query optimizations because of just big kind of like changes by just simply pulling out the query service to its own microservice. There's obviously some variants that will take place based on like database usage at the moment of time of the actual query, as well as like the SSH boxes, like connections that are taking place if the jump box is being used for other services as well. But yeah, that's generally it. Any questions or thoughts?